So hexagon is given. This is the length of one of your diagonals, right? How big is that? 8 feet. 8 feet. What else is given? Each pane is an equilateral triangle. Find the area of the entire window. Now, how can we do that? Idea. So what you guys know? You know that each one of the sides in every triangle that you have here is the same, right? There are many ways to find it. So I know. Do I know how big are these sides? How big is one side? Well, let's look at what is given. I know this diagonal here is 8 feet long. They're all 4, right? I mean, basically, 2 sides make that diagonal, which means one side here is going to be 4. Well, okay, that's 4. What else? Because I have to find the area. How can I find the area of the whole hexagon? Monique. So you need to find what? I mean, you can go with the trapezoid, you can go with the triangles. You know, you just count how many triangles you have here. If you find the area of one of them, then you multiply it by 6 and you're fine, you're done. Or you work with this, with the trapezoids, 2 trapezoids that are pretty much congruent here. Find the area of one of them and go with that. But you're missing one thing, which is what? Giovanni, I hope you're not using your phone. Right? Stand up, please. Right. Thank you. Be careful. I mean, you're looking at me suspicious, and that sells out things. Relax when you look at the teacher, because I may guess some, inappropriate things going on. Okay, so I have to find the area of one of the triangles, or I have to find the height. The height in any one of these triangles will be pretty much congruent to the others, right? So you have this height in each one of them, and let me tell you, will be the same. Why will be the same? Because all these 6 triangles here are congruent to each other. How can I find that height? This height here. I will take my triangles separately, to make it bigger so we understand what are we talking about. I know this triangle has a 60 degree, a 60 degree, and a 60 degree angle, right? Equilateral triangle. If I'm constructing my height from one of the sides, one of the vertices, the opposite side, what do we know about this height? This altitude will also be what? The altitude in an equilateral triangle, or even in an isosceles triangle, will bisect your angle here, right? So this angle will be congruent to that one. Well, let's make it different, please. Okay, so this angle here will be congruent to that one. How big will be each one? 30 degrees, right? Hold on, that's a special right triangle. 30, 16, right? Knowing one side, which we said is what? 4. What can you tell me about the shorter side here? Well, hold on, we don't even need to know that, because we know the shorter side will be what? Half of 4, right? That will be 2. How big is the altitude? Well, I know that if the shorter leg is given to me in this 30-60 right triangle, the longer leg will be found by doing what? How big will be this longer leg? 2 times what? 2 times square root 3. So now you know the altitude, you know the base, height and base. What is the area of this triangle? Will be what? Half base times height, right? Which is what? 1/2 multiply. What is your base? How big is your base? Well, be careful. I'm going with the, well, you know, obviously you can go with the small triangle here. I'm going with the big one. That's 4. And multiply by my height. How big is my height? My altitude? 2 square root 3. 2 and 2 cross, you know, you can cross cancel here. The area of one of the equilateral triangles that you have here is actually 4 square root 3. And if you have to calculate the area of your hexagon, and I'm going to use this, you know, small hexagon sign over there, what will be the area of that hexagon, knowing that you have 6 triangles of this area? Will be what? 6 times the area of the triangle, and that equals 6 times 4 square root 3, and that will be 24 square root 3. Well, 24 square root 3 of what? That's important. What would be this? Inches, centimeters, what kind of feet? Smelly feet, square feet, absolutely. Alright, this is it.